Welcome back to the course on artificial intelligence and soft computing. In this subject, so far we discussed about. I'll quickly recap the things which we learned, right? And we discussed about the different definitions, right? When you talk about artificial intelligence, it's a technique through which we'll try to mimic a human, right? And we are trying to develop a model, that model which is going to think, act like a human, and it takes a decision like a human, right? And whatever the human does very similar to that, we are going to create a clone that will think, act, and do all type of operation which are likely similar to the or likely by to the human. So that is what the reason behind this artificial intelligence technology, right? Then we discussed about the different applications. We discussed about what is meant by intelligence, right? And it is the process of reading, writing, thinking, and then perception, understanding, the feeling, and other emotions, right? Cognitive thinking, all this, the combination of these no the powers, right? And no that is called the intelligence, right? If the person can able to read, write, and then understand the things, based on the problem solving skills, the perceptions, knowledge acquiring, all these things, right? Which which makes the term intelligence, right? Then we discussed about the different dimensions of artificial intelligence. We discussed about think like a human and then act like a human, right? Any expert system model which is developed, so that is going to think like a human, and then which is going to take a decision how the human being which takes the decision, very similar to that, the ability of a mathematical model or artificial intelligence model which take decisions. Then we discussed about think rationally and then act rationally. The term which we discussed is that rational stands for identifying the right thing and then doing the right things. When it comes to the rational, out of a multiple solution to the problem, so your model will try to find out the best one or the optimal solution, right? The optimal solution which has to be identified and that is to be incorporated to find a solution to the real world problem. So these are the four dimension which we discussed under the AASC. Then we started discussing about the different agents, right? We discussed about the intelligent agents, and then we discussed about PAS, right? Performance, and then environment, and then sensor, and then activators, right? Then we discussed about the different types of agents. We discussed about simple reflective agents. Then we discussed about the model based agent. Then we discussed about that the ubiquity based agents. Then we discussed about the goal based agents, right? So these were the different agents, right, which are intended to do the specific task based on that what type of operation or what purpose which has been created, right? In today's session, we'll start with the introduction to the soft computing. So this subject consists of the two portions or two uh, interrelated subject. The first one is artificial intelligence, and then the second one is that soft computing. When you talk about the first three units, which comprises of the artificial intelligence based concepts, right? Again, in the second half, chapter number 4, 5, 6, no, which covers the different technique which are going to come under the soft computing, right? Now, in today's session, we'll have introduction to the soft computing part, and in the 4, 5, 6 chapters, now we will deeply discuss about what are all the technique which comes under the soft computing techniques, right? The soft computing is something that which is initiated in the year of 1981, right? Lofty Zada, and he first published the paper in the title of "What is the Soft Computing?" So, which was the conference was held in the year of 1997. So that was conducted by the Springer International Journals, right? And that, so this was the first the term which was introduced by Zadak, and so he was the first person who proposing the soft computing. When you talk about the definition of the soft computing, is an emerging approach to computing which parallel the remarkable ability to human mind to reason and learn in an environment of uncertainty and imprecisions. When you talk about uncertainty is something that where uh, we cannot take a right decision whether this person win the match or this team win the match. There are two teams, they are playing a match, maybe team A and then team B, right? So for till end of the moment, right, both the teams they maybe with the football. I could say that if the both team both the team they consumed the same amount of goals, two goals. In that cases, it maybe in the last minute or maybe a few minutes before the match, nobody can guess that or nobody can assume that which team who is going to win, right? Very similar to that, something that uncertainty means where there is no certain information or the specific we can with the help of the available information we cannot come to a conclusion or strong conclusions, right? So again, when we talk about the imprecisions, so some operations, right, where the algorithm or the model which will not produce exact outputs or the accuracy output sometimes, right? So there could be the possibilities of that. There should be a misclassification, there should be some errors, right? So this is called a imprecisions. So when we apply this soft computing technique, right, whatever the model which you are going to build, so that will automatically, which will uh, try to act like a human as well as, so that should support for all type of learning and environment in terms of supporting this uncertainty as well as imprecision. So this is what the term which is related to the definition of soft computing. Again, when it comes to the soft computing, which is a multidisciplinary system as the combination of the fuzzy logic, neurocomputing, evolutionary computing, and then probabilistic computing. When you talk about the fuzzy logic, again, the fuzzy logic we are going to discuss in the later section also, right? Again, when we talk about the neurocomputing, so this is a neural network. Already we discussed in the last semester also, right? And so when we talk about the neural network, again it's the neuron based, it's very similar to our biological neuron, right? We'll try to build a model, a neural network model, right, where it consists of the multiple layers, input layer and then output layer. In between you may have the different hidden layers, right? You'll pass the input and then weight value and then functions based on the threshold value, the values, the output will be calculated, and that will be, that information move to the next layer, and the same type of operation will be processed, right? And so this operation repeated, finally we'll get a conclusion whether the particular output is achieved or not. In case of classification, we'll do that, whether we'll do the classification whether the given object is apple or pineapple, or we will classify whether it's a dog or cat. Very similar to that, wherever we need to go for the classification kind of application, in that cases artificial neural network which fits perfectly. Again, when you talk about the evolutionary computing, so this is, I would say that this is a genetic algorithm based on that the human genes as well as chromosomes, right? And so the scientists, they are trying to develop a model out of that available chromes from the parent. If there is a parent, father and mother, out of that the genes know which will be transferred to the child during the transformation, right? Out of the available genes, right, out of the available sets, the strongest one, or which has the more dominant, the perfect one, which has to be selected, and so that will be transferred to the child. So by the way, it will automatically, no, the child will has the ability of their parents as well as by its own. So based on this, the genetic based computations now, the scientists, they are trying to develop a genetic algorithm that will be called as the evolutionary computing. So these are the fundamental basics, are the definitions which are related to the soft computing I was explaining about. So this part also, right? And some of its principal components include artificial neural network, fuzzy logic, and then genetic algorithm. I was explaining so far. Now, when you talk about the soft computing, it is completely depends on the idea of, right, the cognitive behavior of the human mind. When you talk about the cognitive behavior of the human mind, which is an human intelligence, right? Every human intelligence, they have the certain the skills, like by terms of, you will know, you will sense, and then you will perceive, and then you will have the ability to decision making, and then you will cry, and you will have emotional feelings, right? So based on all this information, so this type of the behavior which is called as the cognitive behavior, very similar to that, the scientists, they are trying to consider this as a base. Based on that, they are trying to implement this conceptual of the cognitive behavior in the machines in order to consider or create it as a the intelligence machine, right? So where and all this type of the models or soft computing technique which can be used is that wherever we wanted to find, wherever there is a possibility of finding the exact solutions. That means that whenever in some places we'll get inexact solution, in that situation we'll use soft computing. For example, I could say that some of the example which is incompleteness problem, where there is no known algorithm as of now which has been created, and that can compute an exact solution in a polynomial time. So it's very complex in situations where it's a very complex problem. So this soft computing can be used, right? So which will use to identify that the rough results based on that the errors as well as the uncertainty. So these are the some of the examples are the fields where the soft computing which is going to be really used, right? Again, so when talk about the soft computing has some special features. Now this the soft computing technique, so this is tolerant of, so this can support for imprecisions. When you talk about the imprecision means, right, might be the output might be not exactly 100% correct. There are some chances of misclassification, or might be some errors, and some other there could be some missing data, right? And uncertainty is something that which based on that information, available informations, even a model or a human cannot able to take the correct decisions, or cannot be conclude a concrete solution. So that is called uncertainty. And then partial truth. When we talk about the partial truth, again, so sometimes that instead of finding that whether the person is passed or failed by using the binomial values, other than that, so if the person is passed, and so this was something that which will try to identify that what was the level of the score of the particular student, whether he got the score in between 35 to 50 or 50 to 60, and then 80 to 90. So this is again degree of truth, I could say that the partial truth again, so that can be called as a degree of truth, right? The person might be passed, but the degree of a truth which is going to be that whether 80% is accuracy, or whether the person has scored 80% mark or 70% mark, so that is called the partial truth. Again, the another application or another feature of this the soft computing which will be providing an approximation. So wherever there is no possibility of finding the 100% results or 100% accuracy or 100% solution in that cases, right? So this soft computing technique which will try to provide an approximate solution to the problem. So based on that, the previous history and other informations. Is it clear for all of you what are the basic terms or definitions of soft computing? If you have any doubts, what are the elements or the key term which I used so far, quickly you can write it in a chat box. Okay. Next, we'll quickly cover the topic of the difference between hard computing and then soft computing. Hard computing is nothing but whatever the programming methodology which you are using in our during our practical session or normal traditional calculation. That is called a hard computing. When you talk about the hard computing as a conventional intelligence and requires an analytical model, right? Where suppose if I give you the problem, say for example, if you wanted to find out any the addition value, who is the first mark and who are passed in the examination, right? First of all, you need to create an algorithm. You write an algorithm, or you find out the procedures, right? What are the information available, where to start, and what are the different steps you need to follow, right? Where you can start, and then where you will collect the information, right? So based on that information, say for example, addition of two values, I could say the simple example, right? Where you will start and then start followed by you will get the first number and then you will get the second number and then you will add the two values and then store the results in the memory and then you will display the results. So these are the some of the example, right? Where we will use a normal conventional programming methods, right? We will find out the solution or different steps, right? Which called as the procedure. Based on the procedures, now we will write the programs, right? Hard computing generally requires a pre-written programs, right, and access the fixed set of instructions. So in order to carry out the any specific task, whatever the program language which uses C, C++, Java, and based on the syntaxes and the libraries which are required to execute the program, we'll import all the required libraries, and then we will use all the syntaxes which is given or which is predefined by the language or programming language by means of class input and then output, right? All these things, right, we will write one by one list of instruction or the program will be written in order to carry out the specific task, right? Once if the program has been written, and then we'll compile, and then we'll execute, and then we'll find the outputs. But when it comes to that, the hard computing, right, again it needs a predefined instruction and does not work beyond those lines, right? So when you are executing the program, whatever the lines, whatever the sequence which you written, whatever the loops you have written, whatever the subroutine you have used, whatever the class and other things you have used in your existing program, other than that, you will not be able to do anything, right? Whatever the program you have written in your, whatever the codes you have written, whatever the pseudo codes you have written in your program, that is going to be executed exactly, right? You will not expect other than that. So this program will not give something which is not written in the program, right? Its principle completely rely on certainty and then flexibility, right? Now, when compared with this, the soft computing is another approach, right? Where the approximates which will provide based on the previous thing, which no tolerance for errorness, right? Which will work for that in insufficient answers, right? Again, which may support for the approximates, which will support for partial truth, and then which will support for uncertainty. Now, quickly, we'll discuss the difference in the tabular form, right? Soft computing and then hard computing. The first, when we talk about the soft computing, the first point is that it can be evolved by its own program, right? Only thing is that whatever the machines which you are developing, whatever the model which you are developing, right? Which evolve from based on its knowledge, right? Based on the program, based on the knowledge which we give in the machine or knowledge base, it will take the decision automatically. It will update it. It can take a decision or which may make a moves by its own, right? So this is we are calling as the intelligence machine or the intelligent agents, right? Again, when the same point when we talk about the hard computing, it requires a program to be written, right? There the user or the programmer or developer, he needs to write a program based on the program, and that will be executed and the output will be demonstrated. Again, when we comes about the second point, which is it uses the fuzzy logic. Now, I was explaining about the fuzzy logic, right? Instead of uh, saying the results in the binomial results, pass or fail, right? So this will give the results, right, based on that degree of truth. So again, so that is also another possibilities when we implement the technique called the soft computing. When you talk about the hard computing, it uses only the two values, right? Pass or fail, yes or no conditions, right? Again, when we talk about the soft computing, so this can deal with the noisy data. So also it may accept some errors, which will tolerance for errors, some approximation which is required. All these things which supported by the soft computing. Again, when it comes to the hard computing, it can only deal with the exact data. When you are writing a program, in that cases, suppose we are passing some other data type data, some other data, right? In that cases, so that data type will not be accepted, and it requires the correct data types or correct data, else the hard computing will not provide the correct results. It shows some errors. And when we talk about the soft computing, it allows a parallel computing. Again, when you talk about the hard computing, which will allows a sequential computing, where the programs will be executed line by line only based on that, by what way you wrote the program, and based on your logic, based on the programmer logic, that is going to be executed sequentially, right? Again, so when we talk about the soft computing, the important thing is that it gives the approximate answers, right? So I was explaining about there are some situations or some cases where you will not get exact results. In that cases, this a soft computing technique which will be majorly used to find the approximate or rough answers. When we talk about the hard computing, it gives exact answers. Now here it supports for robustness and it needs accuracy. 100% accuracy we can expect, right? And it is known as the computation intelligence. Now this is the hard computing can be called as the conventional intelligence. So these are the some of the differences between the soft computing and then hard computing. Are you clear with this point? Quickly can write in a chat box anyone, then we'll move further. If you have any doubts, you can write in a chat box based on the terms which I'm using. It might be new for you. Whatever the programming techniques or whatever the programming methodology we are using in the traditional way, all these things which you can correlate with the hard computing. What are the things which you are not doing, right? By means of the program will write your own decision, will take a own decision, will write based on the knowledge base, will take the decision, no, will write a own decision, own programs, right? All these things, no, which will come under the soft computing part. Okay, with this, I'll move to the next slide. In this slide, we are going to discuss about some of the goals of soft computing, right? There are 4 goals already. I discussed about some of the things, right? So which these goals are used to develop an intelligent machines to provide a solution to the real world problems which are not model or too difficult to model mathematically. I was explaining about the NP completeness problem, which which is practically it is very difficult to find the time complexity when it comes to the polynomial calculations. So for that kind of application, the soft computing which will be applied to find out the approximate results, right? So again, the tolerance for the 4 things which I already discussed, I'll quickly move into the next development history. So these are the some of the developmental stage of soft computing, right? The first in the year of 1991, the soft computing which was proposed, which was the combinations of 1943 and McCulloch and he developed a binomial model which we discussed in the last semester also, mathematical model which was proposed by the McCulloch model. Right? The McCulloch model which was providing the results only in terms of zeros and ones. It's a binary mathematical model based on the input it receives, right? It will perform the operation finally once if the a certain threshold value, if the output is exceeds certain threshold value, it will pass the results. Else it will does not throw the results. It will does not pass the results. In that cases, 0. In case if it pass any results, that will be called as a 1. So the McCulloch model, which was introduced in the year of 1943, and then 1963 again Zadak and he proposed that the logic. So based on the fuzzy logic, right? And 1960 again, so which was the first term which was the coined about the genetic algorithm, which is which is the part of evolutionary computing. All these domain which was combined and which we are calling as the soft computing, which was proposed in the year of 1981, which is widely agreed. The soft computing is in another domain which is a combination of multidisciplinary, right? Again, very similar to that again in evolutionary computing, again, which is combination of multiple the fields like the evolutionary computing and then genetic programming and then genetic algorithm. When you talk about the genetic algorithm, later part also we'll have the separate section for that, right? So these are the different combinations of different technologies, right? And as I mentioned, soft computing is not a single domain, right? It is the multidisciplinary domain, right? Where the neural network is there, fuzzy computing is there, and then grid computing is there. All the interdisciplinary domain which are combined to make a soft computing, which is possible to find out a solution to the real-time problem. That output could be might be the approximate results or might be the uncertain results. The first technique comes under that artificial neural network is under the soft computing is the neural network, right? In the last semester, we detailedly discussed about the artificial neural network. I will quickly cover the neural network part, right? See, basically, it is highly interconnected network of a large number of processing elements called the neurons, right? So here, this is an example. I could say that it is the biological neuron, right, where it consists of an axon synapse. When we talk about the synapse, right, so these are the inputs or input nodes through which again the dendrites are the units, right, which act as the input. So this will receive the inputs whenever it gets the receives whenever it receives the inputs, and that inputs will be passed to the axon is the edge, or I could say the link through which that the input result that will be passed to the synapse. When we talk about the synapse, it's an output unit, right? By the way, we can consider that there could be that the millions of neurons which are interconnected, where from one neuron to other neuron, one neuron to other neuron, that information will be passed, and by accumulating all the results, which will trigger to take a decision. Suppose if we get any unexpected sound suddenly, and then sometimes we may turn like this. Suppose if you see any jokes, immediately you start laughing. So based on that, the accumulated results which you perceived from the environment, our brain cells will activate the specific link. Based on that activations, right, you will do the perform or you will perform the specific task. So again, so this is a simple architecture. So here the first layer where we have the number of inputs x1, x2, x3, and then the number of inputs, and each and every link which is associated with that, the input value, and then w is the weight value, right? Weight is something like a priority, right? W1, w2, w3, all this x value, and then the input value, and then w value will be multiplied. X1 W1 plus X2 W2 plus X3 W3, and then weighted sum will be calculated, and then we'll find out the threshold value. Suppose if the weighted sum is more than the threshold value, so that will pass the results, else that will not pass the results. So this is what the simple idea or logic behind the neural network. Again, we discussed about the different types of neural network in the last semester also. I'll quickly cover this, right? The first, the single layer feed forward network, right? When we talk about the single layer feed forward network, again depends upon the number of layer which present in the artificial neural network. Single layer network and then multi-layer neural network. When you talk about the single layer, where there exists of only the input layer and then output layer. When you talk about the multi-layer network, in between your input layer and then output layer of the neural network, there could be that more than one hidden layer which exists in the neural network model. So that is called a multi-layer perceptron or multi-layer neural network, right? When you talk about hundreds of neurons which present in between, or hundreds of hidden layer which presents in that in between your input layer and then output layer, so that is called a deep learning, right? Again, so depends upon that how the informations which are flow from one end to other end, that is called the feed forward network or back propagation network. When you talk about the feed forward network, the inputs will all the parameters which will only move in one direction, from input layer to the next hidden layer and the next hidden layer to the output layer. The input will move from the input layer to the output layer only in one direction. When you talk about the back propagation method, right, in that cases, there is also possibility that from the output layer, in case if it finds any errors, that output will be back propagated to the previous layer, right? From the last hidden layer, output layer to the last hidden layer to the its previous layer, and then that hidden layer to the input layer. By the way, that the transmission of inputs as well as outputs which takes place in both the forward direction and then backward direction. So this is called a back propagation of artificial neural network. Is it clear for all of you? These are the some of the additional information which already we covered, right? Neural network logic, and then supervised and then unsupervised learning, and then when you talk about the supervised learning, again the error correction. Now this already we detailedly discussed the machine learning part also, right? For your understanding, just I kept this slide, and we already learned all these things in the previous semester itself, right? But you need to know that so these are the points, right? Whenever you get the questions, you need to answer for all these elements. What is meant by least mean square, and what is back propagation, stochastic model, and then right, and then reinforcement learning. Next, we'll move into the key term, which is a fuzzy logic, right? When we talk about the fuzzy logic, right, which the theory was proposed by A. Zadak and generalization of classical set theory. So when we talk about normal set theory, right, so if we studied about the sets, right, and in the mathematical concepts, right, where based on the standard rules and regulations, right, and we'll get the only the specific results. So this type of results, whatever we are getting, we are calling as a script set results. Whatever the result which produced by the set values or set operation, so that the degree of membership will be whether it's a 0 or 1. So based on that information, right, it will produce the results. Now, so here you can with the diagram I'll explain, right, what is the difference between this crisp operation and then the fuzzy operation, right? Say for example, this the crisp operation which provides only the two binomial results, whether the particular result is yes or no. Suppose if the output result is 1, so that will be classified as the yes. Suppose if the output value is no, so suppose if the output value is 0, so that will be classified as no category, right? This is an example whether the person Ram is honest or not. So that is the thing. I just wanted to know whether the person is honest or not. Sometimes when I implement the CRISP or normal set conditions method, right? Set operations, I'll find that whether Ram is honest or dishonest. I'll know only these two results. But when I implement the fuzzy kind of things, right? And I'll get more details about the whether the person Ram is honest based on any situation, whether based on the output which I get. Suppose if the output is results, so I assume that it is extremely dishonest. That person is completely dishonest, and depends on situation. Suppose if I get the result which is 0.4, which sometimes I assume that sometimes he may honest, sometimes he may not be honest. When it comes to that 0.8, I may strongly agree that maximum time, no, that person is very honest. When it comes to the complete result, which is 1, I'll assume that always Ram is honest, irrespective of the situation and other factors. If I get one, the result is 1, so that will classify that user has been classified as that extremely honest. Instead of getting this kind of binomial result, yes or no results, if you wanted to move further, if you wanted to get some of the truth about that information which we wanted to acquire, so here within this the two range, right, there could be the different classification, sub classifications, right? Based on that results, again you will be classified. So this is what the difference between normal CRISP operation as well as the fuzzy operations. Now, so these are the additional operation which could be performed. You can perform union, intersection, complement, equality, difference, right? Disjunctive sum, which are very similar to the CRISP operation when it comes to the fuzzy operations, right? Based on the results which we get, and we combine or we can perform these many operations. Next, I'll quickly jump into the topic which is called a genetic algorithm, right? When you talk about the genetic algorithm, so this algorithm, which was initially proposed and demonstrated by John Holland, right? So where this genetic algorithms are used means wherever there is a possibility of finding the optimization algorithm or optimal solutions, right? Now, this genetic algorithm, which will not provide, which will not create any new solution. Instead, that rather, so where we will be feeding the available solution in the genetic algorithm. So based on the parameters, based on the previous solutions, based on the other circumstances and then input values, right? It will try to find out the optimized solutions out of the available solutions, right? Say for example, if there is a problem, maybe the salesman traveling problem, right? Out of the available path, right? And the genetic algorithm will try to find out the specific optimal solution, right? Very similar to that. So now this genetic algorithm which will use for solving the complex problem, right? Again, based on that, the second thing is that the population of the possible solution for a given problem. Say for example, if I could say that if there is a combination of father and mother, right? If from their genes and from their chromosomes, right, out of the million cells or million the other small elements, right, now it will try to get the best one to form a baby. Very similar to that, right? When you talk about the genetic algorithm which uses in similar kind of way, right? So here you will find this option from a group of individuals, right? The best will survive. So this is called a fitness function in the genetic algorithm. Out of the multiple population, out of the available populations, right? Whichever the population, whichever the element which is best fit to the solution, automatically that object or that element which is going to survive. Otherwise, all other elements, all other solution which is going to be rejected without considering it. So this is what the logic behind the genetic algorithm. When you talk about genetic algorithm, right, which will be used for solving the complex problem based on the available populations, from the available populations, whichever the population, whoever is the best, that best solution or the best person will be say elected, right? And so this is specially used to find out an optimal solution out of the available solutions. Now again, so this is a simple diagrammatic representation of are the biological gene and then cells, right? All a living organism consists of a cell. In each cell, there is a set of chromosomes which are a string of DNA and serves as a model for the organisms. Chromosomes consist of genes of blocks of DNA. Each genes encode a particular pattern. Basically, it can be said that each genes code a trait. So here we will be talking about 23 chromes per person, right? Or 23 from father and 23 from mother, and so that will make some multiple combinations, right? 46 chromes, right? And very similar to that, out of the available chromes, right? In case whichever is best fit, right? That will be selected, and so that will create a good solutions based on that. So this will try to create a best solution based on the available, and it will try to follow the specific pattern based on the available the genes. Next, we'll quickly cover off the benefits of the genetic algorithm. It will be very easy to understand, right? And then based on the substantial history and then range of use, and so which will be very easy to adapt in any kind of problems, right? Automatically. So this will try to provide an optimal solutions. So based on that, see here we are going to have a multiple solutions. Out of the multiple solution, your genetic algorithm which try to analyze all type of answers, and that answers no always no will be the optimal solution. So when we are using the genetic algorithm, we assume that always it will provide a best solutions. Now again, next we'll discuss about the applications of soft computing, where and all we are going to use in artificial intelligence, right? Where it needs to take a decisions instead of rather taking a 0 or 1, right? Where it need to take some other type of decisions, right? Maybe the AC, refrigerator, heaters, right? And then washing machines and robotic like emotional pet robots, right? And then food preparation appliances like rice cookers and then game plays. So here, when we talk about the applications of soft computing, where you can automatically incorporate that applications of artificial intelligence, right? With the help of the soft computing only, we will try to use that model, right, which makes a intelligent one. So when we talk about the soft computing, which will try to make a approximate decision, right? Instead of 0 and 1, we'll try to make approximate or partial truth decisions. So next, these are the some of the future scope. Do you have any doubts so far, whatever I've explained? Quickly, let me know. Don't forget to write the attendance in the chat box. Okay. With this, we'll end our today's session. I hope no, I've not bored throughout the day, and almost I took near about 4 sessions, and no other option. Try to gear for it. Okay, let you see in the next sessions as per the